So John Keefe is the senior editor on the data news team at public radio station WNYC in New York. I think you have to say it that way, right? WNYC. His team does data reporting, visualizations, crowdsourcing, and sensor projects. He'll be showing us how journalists can use cheap or do-it-yourself sensors in journalism. And although he won't be flying anything around the room, he will draw on his experience as part of Team Blinky, which I understand is responsible for lighting up all kinds of things in Manhattan, and the Radiolab Cicada Tracking Project. You ready to share that with us, John?
Perfect. Thank you. All right. Hi. Thank you. I have a lot of little things going on over here and only two hands. So going to talk to you a little bit about what we've been playing with, sometimes actually playing, and sometimes actually doing journalism and feature reporting, using this little computer. This is an Arduino. It comes in many sort of shapes and sizes, but at its core, it's a little tiny computer that you can program. You use your computer to program it, and then it just runs on its own. And it can do a lot of things. It can have inputs and outputs. So if you don't know about this, or if you haven't played with this already, I can tell you that people in your community, no matter where you're from, are playing with these things in your community and doing really cool things with them. And so now we're trying to do some cool things too. We were really fortunate to run into this issue. It wasn't really an issue. It wasn't really a breaking news story. Cicadas. Cicadas are these little bugs that come out of the ground in regular intervals, and they make sounds like that. And we knew that they were going to be coming out in our area last year because they come out every 17 years. And it turns out that if you know the soil temperature 8 inches down, you can actually predict when they're going to actually come out. We knew where they were coming out, but what day would they come out? And once the soil temperature gets to 64 degrees Fahrenheit, they will come out. So we thought, wow, wouldn't it be fun to actually monitor soil temperatures all over our region with something like this? And because it takes inputs and outputs, you can attach a thermometer to it and make what we called the cicada tracker. And so we actually decided maybe we'd make a couple dozen of these and put them around our region and track when the cicadas were going to come out in different parts of our region, because the soil warms up in our area from sort of north to south, right? So this was a 29-step process, but you could buy these parts at your local electronics store, and it was really easy to make. I can attest to this because this is my daughter, and she's making one. And what we did is that pole over there is 8 inches down, and it's taking a little reading, and it lights up the little lights, and you can tell what the soil temperature is. So we actually set out to maybe make a dozen of these, or have people make a few dozen of these. Turns out 800 people in 800 places either made this, or you can buy your own soil thermometer from an online store, stuck them in the ground, and took temperature readings all over the eastern United States, which was kind of amazing. These are people who built something, went out, stuck it in the ground, came back, reported their findings, and put it on the map. Okay? So that's a lot of engagement. This is not clicking a like button. All right. So here is the Arduino. I just want to show you. Don't be afraid. This is just a little bit of code, but this is exactly the code that is going to make this little guy. Here's one right here. Make it do that. Okay? Just blink. So blinking an LED in our world is sort of the hello world, I'm alive response from this little computer. And you don't even have to know how to program to get the idea that this is a little loop. This just keeps going around. And it's saying, write a high signal to the LED, wait a second, write a low signal, that's turning it off, and wait a second. That's all it's doing. This is the simple building block for any of these projects. Okay? So what can you do with that? Turns out you can do quite a bit. Here's an example. So Team Blinky the formality of Team Blinky kind of cracks me up because it's really three friends making Manhattans and soldering in an apartment in Manhattan. But this is actually a little, I can't do it with the two hands I have, but this is a little Arduino. This is another form of the Arduino, this little circle. And my friend Liza made a sensor, that's this green thing, that when you bend this, it changes the color of the LED. Okay, this is a simple handmade sensor. It's made out of this little material that can respond to pressure and changes in electric resistance. So you can make a sensor just out of some cardboard and a couple of little pieces of material, and this thing responds that way. That's something that's really easy to make. Anybody know what this is? It's a heart monitor, and it's for jogging. I'm actually wearing one. I won't show you that, but you have to trust me on that. This device I'm wearing is also is communicating with an Arduino that's in my hoodie, and this is actually my heartbeat. Oops, there it goes. You can tell I'm a little nervous because it's going pretty fast. But thank you. This is the Arduino that's sewn into my hoodie right down here, and it's taking the signal from my heart, going to the polar, going to the Arduino, and lighting up the LEDs. Okay, so it's a sensor. It's something that's out there. It's something that you can play with. Does this have a journalistic impact or use? I don't know, probably not. But it was fun to make. This is also, I'm just going to leave this going to distract you. This is actually a lamp I made. Okay, talk about sort of your life and your biology. This is a lamp I made for my wife. And she wanted to, this was her thing to do, she wanted to track her monthly cycles. Okay, this is not me wanting to track her monthly cycles. She wanted to. I want to make that very clear. And what I made is basically, this is a 28-day light clock, and it just changes colors gradually over 28 days. And it sits on her bedside table, and it's an ambient indicator of her biology. And she loves it, by the way, because she thinks this is amazing. But it's basically open sourcing something that's going on in your system, as I'm doing for you now. So this is another Arduino. I have it in my hand here, very little. And it's a little sandwich, and it's got 3 layers, as you can see on the screen. The bottom layer is the Arduino, so that's the little computer. The middle layer is an XYZ orientation detector. So you know how on your phone it knows if you turn it upside down or turn it sideways. That's what this does. And the top layer is an SD card, which is a little removable memory card, which you will have in your phone or your camera, and then it gets attached to a little battery. So Arduino, orientation monitor, and SD card. I put this in a sock, strapped it to my arm, and I went to bed. The idea being, could I detect when I was sleeping with this little device? Anybody have these Jawbone Ups or Fitbits? I've got one right here. You can do that with a Jawbone Up or a Fitbit, but these things cost like $100 to $150. Can you do it just with some little parts? And it turns out that you can. Can you tell when I'm sleeping? Right? Here's me typing, here's me getting ready, brushing my teeth. That's more movement, and then zonk. I went to bed. So clearly I could, and this is just from a simple readout from that little SD card, which is right here, this very one. All right. This concept, this notion that we might be able to track our sleep, and you could do it yourself. You can do it at home, and maybe not with one of these fancy bands, which I like, by the way, but not everybody not everybody has them or could afford them, has led to a project that we launched 3 days ago. This is the WNYC Clock Your Sleep project. We've been working on it for many weeks, and it has just launched, and it's already kind of a smash success. What we're doing is we're inviting New Yorkers to track their sleep in the city that never sleeps, and spend the entire month talking about sleep, how we don't get enough, how you could get enough, and insomnia, and all of these other, we're talking about teens, we're doing lots of different things about sleep and patterns. And you can go online, it's wnyc.org/sleep, and you can every day enter your sleep. When you went to bed, when you got up, and you'll be able to track it. Also, if you do have a FitBit or a Jawbone, you can connect it to this system, and it will keep track of it for you, and you can participate that way. And for the first time, at least in our team, we actually made an iPhone app that allows you to do this too. That was quite an experience, and it's pretty cool, and we're having a lot of fun with it. So this is the Clock Your Sleep project. The last thing I want to show you is another Arduino. Okay, this is the device that's in my hand right here. This is from a company called Spark.io. It started out as a Kickstarter project. It's just an Arduino with a very special thing. It has a Wi-Fi chip on it. It's talking to the internet right now. In fact, you just click over here. If you go to this link, keefe.cc/spark, which I'm going to do, see if it'll go for me. Yeah. Oh, hang on. Just go there. Anybody there? Is it working? Go. Oh, yeah, thank you. Hang on, 1 second. Thank you. You could see that from there, and I can't see that from here. All right, let's see if this is going. Is it going? Do you guys see this? Does it say connecting on yours? Hang on, let me see. Do you have some numbers? There you go. Okay, good. So this thing, we're having a little bit of a Wi-Fi issue. This thing is reading the light off of this little resistor in my hand, and it's getting on the Wi-Fi. I know it's wrong. It's this Wi-Fi connection. It's getting on a Wi-Fi network and reporting that number, that value, the resistance of that light sensor, to this website. Funny, the branded high-tech internet connection is the thing that's not working. My little Arduino is working just wonderfully. I just like to point that out. But the point of this is this notion of Internet of Things, right? You might have heard this about how things are getting on the internet. Your toaster could be on the internet. Your refrigerator could be on the internet. This is kind of how those things are happening with these little devices. But you can do this too. And this is really the point of my talk. I'm just playing with this. I'm not an electrical engineer. I'm not even that great of a coder. And I can teach myself how to do this by Googling things online and playing with them. And they're very inexpensive. So the notion that I might be able to do this, and that people in your community are doing this already, and that you can get your audience to do this, or you could play with it yourself, is something that can lead to journalism and feature stories. And now it's working. There we go. Yay. Okay, so this number will change if I hide this. See how the number jumps to 2,000? So now I put it in the light, it should jump back. Go, go. And if it's working, it might or might not. But this is the kind of thing that you can pull together. These are things that might be good for journalism. We're doing more sensor projects. The sleep project came out of an idea of a sensor project. We have more in the pipeline that are going to be coming out this summer. We're doing this with sensors. And you can do it too. It's not hard. Thanks.